Okay. So, did I hear something that Shelby has to leave at some point?
Yeah.
I do too.
I will too.
Oh crap.
I don't have to till
Okay.
12:50.
So,
I need to leave a little early on
I've never been in this room before.
that. Either.
Yeah.
Wherever you are, be a good one here though.
Okay, so the quiz is only on sections 17.5, 6, and 7. Yeah. So,
Thanks.
alright, well, we probably don't need to pull it up here. We can probably just keep going. So, let's just go through the slides here. It starts on slide 35 through slide 70. Okay, in your chapter 17 PowerPoint presentation. Okay, so it starts with the stomach and goes till the liver gallbladder. So it's just that section. Okay. Let's see. Okay, so while I'm pulling this up, let's talk about the stomach. What are the different parts of the stomach? Anatomy.
The pyloric sphincter, the fundus, the body, and the cardiac.
Pyloric sphincter.
Yep, pyloric sphincter is in the pylorus, right? What is the?
Cardiac sphincter on the bottom.
So where does this food? First of all, what's the name of the tube that leads to the stomach?
The esophagus.
Good. And what's the name of the area of the stomach that food first passes through?
Small intestine. The fundus.
Right after it gets into the stomach. Huh? The gordita?
The gordita?
Gordita.
Oh yeah, the cardia. Sorry, I didn't hear you.
It's okay, I didn't know what I was saying.
No, you're absolutely right. The cardia is the very beginning.
Which is the upper sphincter.
Yes, yep. The lower esophageal sphincter is the name of the upper sphincter in the cardia. And what's the name of the sphincter that is at the end of the stomach?
The pyloric sphincter.
Yes, the pyloric sphincter. Good. Very good. And let's talk about the cells inside the stomach. Okay, remember how we talked about the gastric pits? What were the cells in the gastric pit called?
It's not the pepsinogen.
Yes, pepsinogen is one of the things secreted. What cell secretes pepsinogen?
Chief cells?
Yes. The chief cell. Good. And pepsinogen turns into
Pepsin.
pepsin, right? And what causes that change to take place?
The hydrochloric acid.
Yes, hydrochloric acid, which is secreted by what other kind of cells?
Parietal cells.
Parietal cells. Good. Yes, so the parietal cells. And the parietal cells secrete a few things, right? Hydrochloric acid. And what's the other one?
Intrinsic factor.
Yes, good. Intrinsic factor gets secreted by those cells in the stomach. And what does intrinsic factor do?
Absorbs vitamin B12.
Yes, it's crucial for vitamin B12 absorption. And then there's one other type of cell that's kind of an honorable mention.
Mucus.
The mucus cell secretes mucus. Okay. Alright, so There we go. Stomach, J-shaped pouch, all that. And what are the folds called
Okay.
in the
Rugae.
stomach? Yeah, the rugae. They allow. Why are the rugae there?
So you can expand.
Surface area?
Not surface
Not
area.
surface area.
That's in the small intestine.
Oh,
Stretch.
sorry.
So it can expand
Little
and
stretch.
googly around.
Yes, they allow it to expand when you eat a large meal. Good. Yep, it mixes it around. It's got muscles in the wall. Here's the parts, right? Just like you said, here's the cardia. The fundus is this dome on top.
Oh, I flipped them.
Yeah.
That's what I did.
Yeah, so here's the body, main part. And then the pylorus is this tapering end here. And then the pyloric sphincter is at the very end. Esophageal sphincter is right here in the cardia. Okay. So, yep, these are
I
these
like
parts.
those ones are my favorite. Actually, don't hear that one in the video.
Alright, the cardia, the fundus, the body, the pylorus. So yeah, you guys know where they are. What's the main part? The main
body.
part?
The
Yeah,
body.
it's the body.
The body.
Good.
Is that a trick question?
What's yeah, if you're able to describe them on that level, you'll be good. Alright, so here's the secretions. We're talking about the gastric pits. Okay. So we talked about pepsinogen secreted by the chief cells. Whoop, can't highlight with this. Pepsin is the active form of pepsinogen, and what does pepsin do once it's active?
It digests all types of dietary proteins.
Yeah, proteins, because right, the bonds in proteins are peptide bonds. Pepsin breaks peptide bonds, so it kind of makes that link in your head to help you remember proteins, right? Gastric lipase, we don't know who secretes it, but someone secretes it, and it's a lipase, so it breaks down
Fat.
fats, lipids, good. Hydrochloric acid we talked about, that's from the parietal cell. And the intrinsic factor is also from the parietal cell. Mucus from the mucus cell, the goblet cell. Lubrication protects. Alright. And then this is our little picture. Chief cells here in the bottom. They secrete the pepsinogen. The pepsinogen, on its way up to the stomach, has to pass by the hydrochloric acid secreted by these guys. So it gets activated to go break down some proteins. All right. So, sympathetic impulses versus parasympathetic. Which one speeds up digestion?
Parasympathetic.
Yeah, parasympathetic. Which
Rest
means the
and
sympathetic
Slows.
slows it down. Yep. And that goes with everything GI. Your stomach, your intestines, everything. With hormones, somatostatin, gastrin, cholecystokinin. Somatostatin stops the acid secretion. Okay? Gastrin, what does gastrin do?
Increases gastric juice secretion.
Very good. It pours gas on the fire, right? And more juice. And then our friend cholecystokinin, it does a lot of things. Cholecystokinin is a good one to know because it has a bunch of things that it does. So in the stomach, so I guess what does this here first? It's released by cells in the small intestine. In response to what? Ooh, it's not on. Oh, it is. Dang. When proteins and fat enter the small intestine, okay? Proteins and fat. And it decreases gastric motility, okay? So how do you guys remember that in your mind? The decreased gastric motility part.
I haven't found one yet.
All right.
I
So
feel like you talked about it. We should know.
I know I'm kind of disappointed, but no, just kidding.
I wasn't here.
So the way that I think about it, and I don't know, it works for me, is that these small intestinal cells are, right in the duodenum, that first part, a big chunk of food gets put through the pyloric sphincter into the small intestine, and those cells see, okay, look, I got this protein and fat and this big wad of food that just came through. So they secrete cholecystokinin in part here to tell the stomach, hold on, don't secrete any more. We got to work on this piece that you just shoved in the small intestine. So it slows down the gastric motility to give itself some time in the small intestine to break down that food. Does that make sense?
Mhm.
Food comes in, secretes cholecystokinin to say stop, stomach, for just a moment. Okay? That's how I remember it. Okay. This is just talking about parasympathetic stuff. Releases gastrin, which makes sense, right? Speeds up everything, pours gas on the fire. These are the phases. The cephalic phase, where you smell, taste, don't actually eat, but you start to get gastric juice going. Gastric food phase, when it's in your stomach. Intestinal phase, when it's in your intestines. Mixes with all those pancreatic juices and bile and whatnot. Not a lot gets absorbed in the stomach. Most are in the small intestine. Most of the nutrients get absorbed there. The stomach absorbs some water, some salt, some alcohol, some lipid-soluble drugs. Okay, but your amino acids, your fatty acids, your carbohydrates, small intestine. All right. So, what is chyme?
The food.
Stomach plus gastric juice.
Yes. Food once it's gotten into your stomach and mixed around. Good. Peristaltic waves start in your esophagus, really. And then they just kind of continue all the way through to help push things along. This point here, the lower esophageal sphincter, prevents backflow of chyme into the esophagus, which is good, right? But if things got through there into the esophagus, what would you call it? What's the kind of the general, societally accepted term for this?
Heartburn.
Choking?
Heartburn. Yeah, good. And when you have heartburn, what do you take?
And then antacid.
Yeah, you take antacid. Which, what's the purpose of an antacid?
To reduce the acid.
Yeah.
To suck up the acid.
That's it.
Anti-acid.
Exactly.
I mean,
Exactly. To
It's-
decrease the acidity. Why would you want to decrease the acidity in your esophagus?
because there shouldn't be acid in the esophagus.
Yeah.
It's not stomach acids.
Good. So it decreases the irritation of the lining.
We're gonna have an appointment, and I was gonna ask, are you recording?
Kelsey is, but not for you. Yeah.
No, just not for you.
Oh. Will you share it with me?
As long as Kelsey don't know.
Okay, good. I don't think she's paying attention.
No, it's fine, I wasn't.
Okay, see.
All right. Here we go. As the chyme goes into the small intestine, the duodenum, then you got your accessory organs. What are your accessory organs? Yeah.
Your pancreas?
Pancreas, liver. Yep. Gallbladder and liver kind of go together. Very good. Enter the chyme. Let's start. Stretch receptors initiate the enterogastric reflex, which slows the stomach emptying and intestinal filling. So it kind of does that same thing with cholecystokinin. Vomiting. Vomiting centers in your medulla oblongata. Certain toxins, drugs, overstretching causes you to vomit.
Ugh.
Why can you never mind. How come like I could just puke on command? Like I don't have to stick my finger down my throat. I don't have to do anything. Like I could just puke.
Just flex your stomach.
Why not?
Whenever.
If you puke
It's not
on
like-
command, I will puke on command.
I'm not gonna puke, but I'm just saying.
That's a good.
Like, why?
I don't know.
That's like one of those like stupid human tricks. Like,
Yeah.
That could be your superpower.
Yeah.
Yeah, a little bar trick.
America's
My
Got
poor
talent.
mom.
Yeah.
All of school times. Mom, I'm throwing up. Prove it.
Yeah, so that's all to learn from that slide.
That's all well done. That Shelby can do it on command.
That's all, sorry.
We can do it on command.
She has a very strong medulla oblongata.
Yeah.
That can be like, do it now.
It's powerful.
She works out.
Hulk.
Work out.
I don't know why I can, but.
Yeah, so this slide here just shows that the stomach, in addition to peristalsis, pushing everything forward, it also does this churning contractions of the muscles in the wall to kind of mix things up, to get all of the food mixed with the juice so it can digest. Here's the enterogastric reflex. It's just the reflex for stomach emptying, speeding up, slowing down gastric movement with the brain. Common problem, heartburn, we talked about that. Antacids, we talked a little bit about this. Takes 20 minutes for the hypothalamus to sense the full stomach. With help from what hormone?
It's
Close
It's
CCK.
no, the ghrelin's on.
Did we talk about
Ghrelin?
this?
No, it's Ghrelin.
Ghrelin.
Not ghrelin.
Ghrelin is the one that
Ghrelin
says that
tells
it's
you.
hungry,
Yeah.
and then
And
it
it's-
sends it to the hypothalamus.
I know it too, and I wasn't even here.
Oh my gosh, acetylcholine.
No.
I don't know.
It starts with the L.
Lipase?
Close.
Lectin, no.
What'd you say?
It is like.
Leptin?
Leptin. Yeah, good. Leptin gives you the sense of fullness. Ghrelin makes you feel hungry. Good. Not that you need to know that for the test, but
Oh,
What?
so
yeah.
great.
You're not gonna give us anything easy, are you?
Oh, no. No.
I will
So eat
punish
small
you.
meals, eat slowly, stay upright after eating, avoid caffeine, nicotine, alcohol, blah, blah. Okay? Pancreas. So now we're to the next step. Endocrine gland and exocrine gland. Okay? What are the endocrine things it secretes? Hormones?
Insulin and glucagon.
Insulin and glucagon. Good. They regulate blood glucose. But we're more talking about the exocrine part, right? The GI part. And it secretes all of these, a bunch of these things, which we'll talk about in detail on the next slide. But the cells that make the juice of the pancreas are the pancreatic acinar cells. Okay? Those acinar cells secrete their juice into the pancreatic duct. Pancreatic duct carries that juice and dumps it into the duodenum. Okay? Through the hepatopancreatic sphincter. That's just the name of the sphincter at the opening into the duodenum. Controls the amount going in. And what else goes through that sphincter?
Gallbladder.
Not the
Bile duct.
gallbladder.
Bile.
The bile from the gallbladder. Yes.
Biles up, yes.
Very good. Excellent. Alright, so here's a picture of the structure of the pancreas. Right there, remember there's the chicken tender?
Oh,
Yes. And then you got the gallbladder here. And the gallbladder connects to the bile duct here, right? But what's the name of, what's the name of this actually, we'll get there in a second. We're talking about the pancreas right now. So that's what it looks like. This is the pancreatic duct, which leads down hepatopancreatic sphincter into the duodenum. Now let's talk about the juice. Has all these enzymes in it. Pancreatic amylase. Amylase does what?
Split starch and glycogen.
Yeah, starch, glycogen, carbohydrates. Breaks down carbohydrates. You also see this in the saliva. You have salivary amylase and pancreatic amylase. Both do the same thing, carbohydrates. Pancreatic lipase breaks down lipids, yeah, triglycerides, good. Trypsin digests protein. Trypsin, protein. It doesn't have like protease. It is a protease because it breaks down proteins, but it's got the special name, so it kind of throws people off. So remember, trypsin, proteins, okay? It's released as trypsinogen. It's kind of like pepsinogen in the stomach, gets converted to pepsin, its active form. Trypsinogen gets secreted by those pancreatic acinar cells, and it gets activated to trypsin inside the small intestine. Okay? Trypsin, protein. Chymotrypsin, protein. Carboxypeptidase, protein. These two, chymotrypsin and carboxypeptidase, are kind of lesser important ones. Trypsin's the big one to know. Okay? Nucleases. Yep, nucleic acids, perfect, nucleosides, right on. And then bicarbonate,
Makes it less acidic.
yeah, it's a base. So all of that gastric juice is coming into the duodenum. It's really acidic because it's from the stomach. And this bicarbonate neutralizes it so it doesn't cause damage. All right, here's those hormones, okay? These are the tricky ones, okay? Secretin and cholecystokinin, or CCK. What does secretin do?
It secretes.
Yeah.
Stimulates pancreas juice.
Good. So both of these, secretin and CCK, are released by cells in the duodenum. Okay? They secrete secretin, saying, hey, we just got a load from the stomach. We need some pancreatic juice. So get secretin. See that little word there?
Dad joke.
I'm working on it.
I liked it.
I like it.
Okay, so the secretin tells the pancreas to release juice, right, with everything in it, but particularly with bicarbonate to neutralize it and break down everything. CCK stimulates the pancreas to release pancreatic juice high in enzymes. Okay? So both of them get secreted. So we know two things about CCK so far. It does what to the stomach?
It slows it down.
Slows it down. And what does it do to the pancreas?
It's the
Yeah,
juice
yeah.
is going.
Gets it to get some juices with some enzymes to break down the stuff. Nervous system regulation during these different phases. Parasympathetic impulses stimulate the pancreas to secrete enzymes. All makes sense. Parasympathetic stimulates everything to go more in the GI tract. Okay. So you can look at this if you like. This is just kind of describing what we just talked about. And let's talk liver and gallbladder. Okay, so the liver is the largest, reddish brown, lots of blood vessels. We've got different lobes and lobules inside these lobes, made up of these hepatocytes. Okay, you got the sinusoids, portal vein, hepatic artery, and the bile duct. Bile is made by those hepatocytes and secreted into the bile duct.
Sorry.
Oh, you're good. No worries. No worries. Okay. So here's your liver. And this is your lobule. Okay? The little hexagons everywhere. In the center of the lobule, you've got the central vein, right? And then at each corner, you've got this triad. You've got the hepatic artery, hepatic portal vein, and the bile duct. Okay? Both of the hepatic artery and hepatic portal vein bring in blood that flows through this sinusoid, this little ravine here, towards the central vein. So all these corners bring blood that all drains into the central vein. Central vein carries it away And where does it end up?
In the heart?
Yeah, pretty much. Yeah. It goes into all these central veins combine to form the hepatic vein, which leaves the liver and plugs into the inferior vena cava. Good. So, hepatic artery brings blood that is rich in oxygen. Good. Hepatic portal vein, not so rich in oxygen, but what makes the hepatic portal vein unique? Where does the blood come from?
Nutrients from the gut. No.
Yeah. Yep. So, the hepatic portal vein is coming straight from the gut, right? So all those lipids, all the fatty acids, the amino acids, the carbohydrates, all the other things that are absorbed in the gut go from the gut into the blood. The veins that are carrying that blood, or the capillaries, turn into veins, which is the portal vein. It goes straight to the liver, right here. Okay? So all of those things that were just absorbed via the gut, all of them pass through a lobule in the liver. And so this is how the liver kind of cleans the incoming blood, the incoming nutrients. Okay? So that's going on. And at the same time, all these hepatocytes are making bile, and they dump it into the bile duct, which goes the opposite way, out the bottom of the liver. Okay? And then you do have these macrophages in the sinusoids that have a special name, the Kupffer cells. They're just macrophages. Do what macrophages do, they phagocytize stuff. So the liver does all these things, a whole bunch of stuff, okay? We won't go through that right now. You can kind of gloss over that. Major function of the liver, right here, it does all these things, and they're wonderful.
They're just wonderful.
Yeah.
All around.
Replacing the liver, you know, there's some interesting facts about the liver. It can regenerate. Yeah, it's kind of a extra slide there. And then the bile, what does the bile do?
Secretes.
To emulsify fats from salts.
Yes, what does that mean?
I don't know.
The salts, there's salts in the bile, they're called bile salts, and they emulsify fat, right? So they break down big fat globules that you eat into little tiny fat globules that your body can break down and absorb easier, okay? So it's just a big part of fat breakdown, so you can absorb it. Okay, bile. That word emulsify. I don't think I've ever seen it anywhere else in the human body, except for right here, with bile. All right. Bile pigment, bilirubin, and biliverdin, which are from hemoglobin breakdown. There are components there. Cholesterol is also a big part of bile, and some electrolytes, and some water. Okay. Jaundice is if you have too much bilirubin. Things turn yellow. Can be a problem if it gets way too high. Here's the hepatitis. I have A, B, and C, transmitted by different things. B and C are through contact with body fluids, blood contact. Hepatitis A is fecal oral. So, contaminated food contaminated with feces of somebody who has hepatitis A.
Oh.
You'll get it that way.
Filthy.
Yeah. So, wash your apples. Alright. Gallbladder. Pear-shaped sac on the bottom of the liver. the cystic duct. What is the cystic duct?
Forms the common bile duct.
Yes. So if we were to look at this, okay, so here is your gallbladder. This part that connects the gallbladder to the bile duct is the cystic duct. So if you got your gallbladder removed, they cut the cystic duct to take away the gallbladder. Does that make sense? All right. So this is the hepatic duct, common hepatic duct, coming from the liver. The cystic duct carries bile coming from the gallbladder, and they merge to form the common bile duct. Okay? Yeah, merges with the common hepatic duct to form the common bile duct. Gallbladder stores bile. The hepatopancreatic sphincter we've talked about is at the very end on entrance into the duodenum. And stones. Okay? Stones is from basically the second bullet. Sometimes cholesterol precipitates and forms solid crystals. Okay? Crystals can enlarge, forming gallstones. Causes of this can be excess bile concentration, too much cholesterol secreted by the liver, which can lead to being too concentrated, or inflammation of the gallbladder. So remember, see, it's too concentrated, so concentrated in fact, that it starts to form crystals. Okay, that's also.
Cholesterol is so concentrated.
Mm-hmm.
Okay.
Yep. Bile release is under the control of our friend
CCK.
CCK, cholecystokinin. All right, so let's go through those three things again. Cholecystokinin does what to the stomach?
It tells it to slow down.
Slows it down. To the
Speeds up
pancreas.
the pancreas.
Speed it up. Secrete more enzymes in the juice. Enter the gallbladder.
Contracts it.
Causes it to squeeze. Stimulates the contraction of the gallbladder. In so doing, squirting bile into the duodenum.
It's a busy word.
Mm-hmm.
Yeah.
Little guy.
Cholecystokinin, man.
Cystokinin, whatever that is.
CCK, just
Yeah,
it's
that
just
one.
easier.
That.
That's right.
3 letters does 3 actions.
Yeah, there you go.
That's how I like it.
There you go. Acts on all of the major organs. Alright, so function of the bile salts, we talked about this, it emulsifies, emulsification, breaks up large fat globules into small ones so that the enzyme lipase can act on the small droplets after it's been emulsified. Okay, and break it in. And so when you absorb fat, that allows you to absorb fat-soluble vitamins that are dissolved in the fat. A, D, E, and K.
B and C.
Almost all
All
bile salts recycle. Gallbladder disease. Yeah, you get pain, you do tests. Ultrasound is a good one. You can look at the gallbladder. You can see gallstones in the gallbladder, cystic duct, hepatic ducts, or common bile duct. So it can be anywhere in there. The gallstone can get stuck. Treatments could be removing the gallbladder, cholecystectomy, or endoscopy to find stones and remove them from certain areas. So you can put a little camera with the basket down through the stomach into the duodenum, kind of reach up and grab the stuff.
I don't like that.
That's so cool.
Yeah.
I like it.
That would be if it's pretty close to the hepatopancreatic sphincter. If it's like way up in the gallbladder, I mean, they probably just take the gallbladder out. Alright, so here's all the hormones. Okay? We can go through these real quick. This is the last slide. So gastrin acts on
There's your alarm. It's time to go.
the stomach, right? And it basically increases the gastric gland's secretion of juice. Pours gas on the whole thing. Intestinal gastrin kind of does the same thing. It's secreted from the intestine, but it acts on the stomach to pour gas on it. Somatostatin comes from the gastric cells, inhibits the secretion of acid by the parietal cells. Intestinal somatostatin, secreted from the intestinal wall cells in response to fats, inhibits secretion of acid, so slow down stomach. Cholecystokinin, this is our big one, secreted by those cells in the intestine in response to protein and fat. And it decreases secretory activity of the gastric glands and motility, goes down, stimulates the pancreas to secrete fluid with enzymes, and stimulates the gallbladder to contract and release bile. Gallbladder, pancreas, stomach. And secretin, secreted by the cells in the small intestine, the duodenal wall. Secrete that pancreas juice with bicarbonate. Okay. And that's it. That's everything. Everything on the quiz is contained in those slides.
It's like 35 through 70.
You can do that.
Yeah.
Okay.
I think I think you'll do well. This is the more simple of the quizzes we've had.
Easier. I like it.
I know, right? I like it.
I like this too. These chapters are going well for me.
Yeah. GI tract, I like.
Thanks for doing
This is
these
hard.
reviews.
Yeah, no worries.
Yeah, thank you so much. And we'll have one next week.